Hello everyone, welcome back to Leumastudio. In this section, we are going to be looking into drawing of exterior tangents of a circle of different diameter. So having two different circles of 25 millimeters and another circle of 10 millimeters of radius and with a distance of AB of 55 millimeters apart. Draw an extensive horizontal line at the center of our drawing sheet. Next thing is to draw our circle of 25 millimeters of radius and also 10 millimeters of radius, and to do that we measure the radius on our ruler as 25 millimeters from any point on the line. So we draw the first circle and label the center point as point A, small letter A, and then the distance between the first circle, which is 25 millimeters, and the second circle is given as 55 millimeters. So from the center of the circle, which is A, we measure a line, a length of 55 millimeters. So we have 55 millimeters at this point. So from the point which is 55 millimeters, we draw our circle which is 10 millimeters of radius. So we have our 10 millimeters. And we label this as point B on the smaller circle. So we have our R, which is 25 as the big circle. We have the R, which is the 10 millimeter as the small circle, and then we have distance from point A to point B as 55 millimeters. So for constructing an exterior tangent, we have a formula R minus R for exterior. So for the interior, we have it to be R plus R, but for the exterior, we have it as R minus R. So the next thing to do is to bisect the midpoint between A and B. So to bisect the midpoint between A and B, we make use of our compass marking an arc from above and below, coming to the other side to mark an arc from above and below. So we have our point of interception as this and this. So we join the 2 points of interception together. Okay, so after joining the point of interception, the next thing is to draw a semicircle from point A through to point B from the center point, which is noted as point C. Okay, so after drawing the semicircle, the next thing we do is to make use of our formula given for exterior tangent, which is R minus R. So we have our bigger R to be 25 millimeters minus 10 millimeters, which is the small r, which is equals to what? 15 millimeters. So we are going to be making use of our 15 millimeters to draw an arc inside the bigger circle to cut the semicircle. So making use of our ruler, we're going to measure a radius of 15 millimeters from our circle, radius of 15 millimeters, and then from point A we mark an arc that touches the semicircle. So at the point which touches the semicircle, we have the point E, the point D. So from point A to point D, we are going to join those 2 points together to have a new line which should be recognized as point N. So we have the line NA. So we are going to be extending the NA to point B as a parallel line. So to do this, we are going to be making use of our ruler and our set scale. So we're going to place the longest side of our set scale on line NA, and then we place our ruler below it, ensuring that the ruler is stationary while the set scale is able to move freely on the ruler, and then we extend it to point E and draw out a new line which should be recognized as NB. So from this point of interception from the circle to the line, we are going to join it to the point of interception between the small line. So I'm going to be recognizing this as point H, and I'm going to be representing this as point G. So we're going to join point H and point G together to get the tangent of our exterior circle of different diameter. So we have our big diameter, big circle, and our small circle. So to draw the tangent, now we join H and G together. Our tangent, which is 90 degrees to NA, 90 degrees to NA, and 90 degree at point G as the second point. So with this, we have successfully constructed our tangent, which is meant for circles of different diameters. Thank you.